I'm sorry. This keeps my phone full, so I take out some photos and videos. Okay, so we converted 300 degrees. So again, times it by pi, or 5 times 180. Sorry, 5 times 180 divided by 3 is 300. If you graph 300, it's not exactly. This would be here. And then the second angle would be 60 degrees. Okay, because this is 360 degrees. 360 degrees. So 360 minus the 300 will give you 60 degrees. Okay, so the two angles then are the 5 pi over 3, because we want our final answers in radians. So 5 pi over 3 and our 60 degrees, which we found out, 60 degrees up over, oh, it's on the other page, is pi over 3. Okay, so those are the two angles, and then it says, what is the sign of the ratio? So we're looking at cos, and we're in this quadrant, so cos is positive. So we're going to be positive here. Okay, so 300 degrees, 60 degrees, and positive. Okay, next one, secant. So first we're going to find out what angle this is. So 5 times 180 divided by 6 is 150 degrees. So 5 times 180 divided by 6 is 150 degrees. So 150 degrees is going to fall in the second quadrant. So we have 150 degrees here. Okay, so we have to find the related acute angle. So related acute angle, which is your beta. So this angle here would be 30 degrees, because up to here, so this is 180. So 180 minus the 150 gives you 30 degrees. Okay, so our two angles are the 150 degrees. Then we have our 30 degrees, which is pi over 6. Okay, 180, just convert this, times by pi over 180 and reduce, you get pi over 6. And in this quadrant here, so we have CAST, and we want to know if it's going to be positive or negative here. So secant is the reciprocal of cosine. So is cos positive or negative here? Well, it's a negative. Okay, so if cos is negative, then secant is negative as well. So in this quadrant, we have negative. All right, going further. Okay, number 2. Sketch each angle, find the value of r, and calculate the radian value of theta. Okay, so we're going to graph this -12 and -5. So -12 and -5 would be somewhere over here. I'm just estimating, it doesn't have to be exact. Okay, so we're going to draw our triangle with a 90 degrees. So -12 is your x value. So -12, and then we go -5. So our x is -12, and our y is -5. So what we want to find is our radius now. Okay, but when we're plugging into Pythagorean theorem to find r, we use positive values. So we have a squared plus b squared equals c squared. So c is your radius, and then a and b are the other two. So sorry, c squared, so c squared is r squared. Or we could do is x squared plus y squared equals r squared. Okay, so x, y equals r. So we have 12 squared plus 5 squared equals our radius squared. So 12 squared is 144 plus 5 squared, which is 25, will give you 169. And then lastly, to solve for r, we square root, and the square root of 169 is 13. So our radius is 13. Okay, and then this is calculating the radian value of theta. Okay, so theta, though, is your principal angle. So the principal angle goes all the way from the initial arm to our terminal arm. So we can't calculate this as it is because it's not inside the triangle. Only part of it is, not the whole thing. So first we have 180 degrees is outside of the triangle, and then we have this piece here, which we need to find out. Okay, so this part here inside of the triangle is your beta, which is your related acute angle. So we're going to find that. So we could use any of the sides to determine what beta is. So we could use opposite over hypotenuse. We could use adjacent over hypotenuse, or we could use the opposite over adjacent. It's up to you. Okay, so I don't know. I like using sine, so I'm going to do opposite over hypotenuse, or it's your y over r. So I'm going to put over here. So sine beta we're looking for is the opposite, or our y value, which is 5, and over 13, which is our radius. Okay, so recall, when you're finding the angle, you bring your sine over, and it becomes inverse. So whenever you're looking for an angle, you need to have the inverse function. So we have the sine inverse of 5 divided by 13. So I'll just plug that in my calculator. So the second function, sine 5 divided by 13 gives me 22.6. So our beta is 22.6 degrees. It doesn't say to round. Okay, but that's beta. What the question wants is our theta. Actually, I'm going to round this. No, that's fine. So we want our theta. So theta, which is our principal angle, goes from 0 all the way to 180. And now we're going to add the 22.6, which we just determined. So 180 plus 22.6 gives you 202.6 degrees. Okay, and lastly, it wants the radian value. So now we have to times by 3.14, or pi over 180. But actually for the radian value, since it's a decimal, we're actually going to go 202.6 times pi, which is 3.14, divided by 180. So let's see. So 180 times, where's my pi button? Pi. Sorry, that's wrong. It's 202.6 times pi equals divided by 180. Then we get a radian value of 3.5. So it is 3.5 radians. So we put rads. Okay, number 3 now. Determine the exact value of each. So now we're going to flip the page. The exact value of each. Okay. Okay, so 5 pi over 4. So I'm going to convert to degrees so it's easier for me to work with. 45 is 225 degrees. Okay, so 225 degrees would be in this quadrant here. So we're going to go all the way here. So our theta is 225 degrees, but we are going to deal with, since we're doing exact value is special triangles. When you see exact, special triangles. Whenever you see exact value, you're going to be looking at special triangles almost always. Okay, so 225 degrees would be in this quadrant here. But in order to use a special triangle, we need to have an acute angle. This is an obtuse angle. Okay, it's larger. Sorry, it's a large angle, so we need the acute angle here. So if the whole thing is 225, so from here to here is 180, but from here to here is 225. So if you subtract them, so 225 minus 180 will give you 45 degrees. Okay, so 45 degrees. And we're looking for cos. So cos of 45 degrees. So if we do our special triangles, this is a 45, 45, and 90. You get 1, 1, and root 2. Okay, so cos is adjacent over hypotenuse or x over r. So 1 over root 2. So 1 over root 2. Okay, I'm not sure if you remember doing this in grade 11, but we have a radical in the denominator. Okay, so we don't want to have a radical in the denominator. Okay, so we have to get rid of this radical. And the way you do it is you multiply it by itself. So we're going to multiply by root 2. Okay, so in the numerator, we get root 2. So 1 times root 2 is root 2, and then root 2 times root 2 is root 4. Okay, and then the square root of 4 is 2. Okay, so our final answer is root 2 over 2. But I am missing one thing. In this quadrant, we started with cos. Okay, in this quadrant, is cos positive or negative? It is negative in this quadrant. So then our final answer needs to be a negative root 2 over 2. Okay, I'm just going to pause the video